Hi all, and welcome to a new chapter of Principles of Macroeconomics. Today we are going to review how to think as an economist. In particular, we are going to review chapter 2 on MenQ. Just give me a second, there is a runner passing. So, first of all, we are going to review the role of assumption. Then we discuss how economists use model in order to rationalize the world. Then we are going to move to we're going to discuss a couple of models that you have already seen in Principles of Macroeconomics. Then we are going to discuss the difference between positive and normative statement. And then we conclude with some very useful concepts, which is the one of omitted variable and the one of reverse causality. And these are concepts that are used when we want to make, if you want, and we want to try to understand how to make causal claims. So let's start this new chapter. So let us start with the role of assumptions. Now, economists they want to explain very complex phenomena. As instance, the impact of this COVID crisis on the macroeconomy. Now, these are very complex phenomena. Now, there is an epidemiology literature that talks about how the virus is spread, the type of the virus. You want to abstract from all these details. Now, how economists abstract through all these details? Well, by making assumptions. You can think about assumptions as a way of simplifying the real world and focusing only on the characteristics that are relevant in order to answer the question that you are after. Now, model in this sense represent the way in which economists formalize their theory. So a model is made of assumptions that simplify, if you want, the real world. And model, most of the time, they also use mathematics, but it does not only to be a mathematical model. It could be a graphical model. You can have, a supply or demand. It could be just an argument. In general, we use mathematics just to make our points as clear as possible. Hi. Hello. So, what is very important is that when economists design models, they design a model in order to answer a particular question. Now, each model that you're going to see is always targeted in answering a particular question. Just to give you an idea, this pair, question and model, is basically a cornerstone of the way in which economists think. There is, you cannot have a model without having a question. And in particular, not all models are good to answer a particular question. So the first step when you want to think about a phenomenon is, what is the question I want an answer for this particular phenomenon? Once you define your question, at that point, you start making assumptions about the things that you think are not relevant in order to answer this question. And then you start formalizing your answer through a model. You describe the setup of the environment that you want to describe, and then use the model in order to get some insights. So, just to give you something, maybe this was too elaborate. A model, you can think about a model as a map. Now, a map, first of all, serves a purpose. What is? It is to go from point A to point B. Now, and this is, if you want, the question. How do I get from point A to point B? So, in order to answer this question, well, we want to simplify the real world. If you can see, as instance, this trail is, by the way, is beautiful, but is really, if you want, is a complex, if you want, phenomenon. There are trees, there is grass, there are animals. Now, I just want to go at the end of this trail. So what a map does, it gets rid of all these details. This will be our assumption, get rid of all these details that are unnecessary in order to tell us about how to go from point A to point B. And at that point, the model would be just, if you want, a graphical model, a spatial model, which is the map, which tells you you start from A and you arrive to B in this way. And of course, as instance, think about Google Maps. Google Maps does not only have the future. I mean, maybe you don't want to use the map only for going from point A to point B. You want even to know where is, a gasoline station, or you can find food, and etc. So for this, basically Google allow you to include other ingredients in the map if you want, which means relaxing the assumptions behind the map. I hope this one makes clearer the relationship between model and question. There is no model without a question, or if you want, a model is useless without a question. And then how do we use assumption to get from the question to understanding of the phenomenon via the model? Let us now review together a couple of models that you have already seen in Principles of Macroeconomics, in particular the circular flow diagram model and the production possibility frontier model. Now what I want from you is to focus, first of all, what is the question that we are trying to address with each particular model, and then the assumption that we are going to make in order to provide an answer to that particular question. So let's look at them in turn. So let us start reviewing the circular flow diagram. Now, first of all, what is the goal of this model? Now, the goal of the circular flow diagram model is to try to understand how dollars on one side and goods on the other side circulate across markets between firms and households. So in order to capture, if you want, these flows, we need to make assumptions. In particular, there are several actors in the economy. There are not only households and firms, there is also, as instance, the government, and also there are different types of households. There are married couples, singles, and there are different types of firms. There are, corporate firms and non-corporate firms. So what we want to do is to simplify, if you want this word. So we are going to assume that there are only two actors, which are households and firms. So we are going to abstract from all these details. Then we are going to look only at basically two markets. We're going to look at the markets of goods and services and the markets for the factor of productions. What does it mean? Firms and households are going to meet only in these two markets. Are going to meet in the markets of final goods. So households are going to purchase the final goods produced by the firms and are going to meet in the markets of the factors of production. In particular, where firms buy from households the factors of production, buys their labor, buys their capital, and so on and so forth. So let us look at that. So what are the factors of production? Now, the factors of production are the resources that the economy uses in order to produce the final goods and services. And these include labor, includes land, and include physical capital, so the building and the machine that are used in the production. So what the circular flow diagram model looks like? Well, on one side, we have the household. On the other side, we have the firms. These are the only actors that we are assuming live in our economy. And again, this is an assumption. There are actually other players. There are banks, there is the government, and so on and so forth. Now, the households own all the factor of production. And what they do, they sell and rent these factors of production to the firms. And again, you can imagine that this again is a simplifying assumption. We are thinking about a household as a representative household that owns all the factors of production. But as instance is the case that I'm offering here in the United States as a factor of production my work, but I don't own any land here in the United States. And similarly, there are households that own capital, but they do not supply the labor. So in this case, we are simplifying all of this. So households, what they do, they own the factor of production and sell and rent them to the firms. And with the proceedings that they receive, with the income that they receive by selling, if you want, the factor of production, they buy the goods and services that are produced by the firms. On the other side, what the firms do? Well, they buy and hire the factors of production from the households in order to produce the goods and services, and then they sell these goods and services to the household. And again, that's not always the case. It's not always the case that the household buy all the possible, goods and services that are produced by the firms, but here we are simplifying. We have a representative household and we have a representative firms. Again, the role of assumptions. So, the goal of this model is to illustrate, if you want, the flow of goods and dollars in this economy. So, let us start basically from the flows of goods. First of all, the households supply particular goods, which is the labor, land, and capital, to the firms. So they meet with the firms in the markets for the factors of production. And what it happens? Well, the firm in this market, they buy and hire these factors of production. So in exchange of these factors of production, the firms gives wages to repay the labor, rent to repay the land, and profits to repay the capital to the households. So you see that in red, we have the flows of, let me see if I can use actually the laser point. Yep, in red, we have the flows of the goods. And in green, we have the flows of the dollars. Then there is another market in which the firms and households will meet, which is the markets of the final goods. In particular, the firms is going to produce basically goods and services that is going to provide in the markets of goods and services to the household that is going to use its income in order to buy these goods and services that are produced by the firm. So in terms of flows of dollars, what we will have? We will have there is a flows of wages and rent and profits that goes in the form of income to the household that uses this form of income in order to spend to buy the final goods and services, which represent the revenue of the firms that the firms use in order to repay wage, rents, and profits. On the other side, we have the red, which is the flows of the goods. The household provides labor, land, and capital, which are the factor of production that the firms use in order to produce the goods and services that are eventually sold to the households that basically consumes them. And this is basically the circular flow diagram model. In particular, this is, as you can see, is not a mathematical model, it's a graphical model. The purpose of this model was to, if you want, address a particular question, which is what is the flows of goods and dollars in this economy. And we see how we made this assumption to make this point as clear as possible, with only two players, firms and households, on only two markets, the markets of goods and services and the markets for the factors of production. So let us discuss now the second model, the production possibilities frontier. Now, the goal of this model is to show the combination of two goods that an economy can produce given the available resources and technology. The idea is like pile all the resources and technology that an economy has, and let's see what is the maximum amount of two goods that this economy can produce. So, for this, we are going to make a bunch of assumptions. First of all, there is a variety of goods in an economy, car, televisions, etc. Here, we are going to assume that there are only two goods, which are computers and wheat. The second, basically, an economy is rich on many resources. In particular, we have seen before that there's labor, land, physical capital, intangible capital, and so on and so forth. Here, we are going to assume for the goal of this model, just that this economy has labor. Now, importantly, you have to remember that our goal is to use a model to make the point as simple as possible. So we're going to use all the assumptions that we can, such that we can make a point as simple as possible. And this is, in general, a lesson that is valid everywhere in economics. The purpose of a model is to make assumptions such that you can make a point as simple and as concise as possible. You don't want to belabor stuff, okay? So ultimately, we are just putting some numbers, so assume that we have 50,000 labor hours per month available for production. So let us start with a clicker just to familiarize a little bit of what can we do with these 50,000 labor hours. Now here you can see that with 50,000 labor hours per month available for production, and we are going to assume that to produce one computer takes 100 labor hours. So the question is, how many computers can the economy produce with half of these labor hours? So we have 50,000 labor hours. Let's suppose that we devote half of these labor hours, like 25,000, in order to produce computers. How many of these computers can we basically produce given this particular technology? Which means basically the technology is telling us that we can produce one computer with 100 labor hours. And of course, you have to divide 25,000 labor hours by 100 labor hours, and this basically will tell us that we can produce B 250 computers. So the solution here is B 250 computers. So here I'm showing you one of the ways in which we can represent the production possibility frontier. In particular, this is a tabular representation of the production possibility frontier. On the left, you have basically the amount of resources available in the economy. On the right, you have the two goods. Again, the goal is to understand basically, based on the production possibility frontier, is what is the maximum amount of the two goods that we can produce given the available resources and the technology. The first two lines, line 1 and line 2, are telling us about the technology. In particular, producing one computer requires 100 hours. So this is a technology that requires 100 hours for one computer, and 1 ton of wheat requires 10 hours per labor. So the idea, we have 50,000 labor hours. This is the total amount of resources. We can devote these labor hours for producing computers or for producing wheat. So we can put all these labor hours to produce computers, and we get then 500 computers, 50,000 divided by 100. We can put then eventually all the other possible combination, which is 40,000 and 10,000, 25,000 and nothing, 10,000 and 40,000, 0 and 50,000, where we are specializing in producing the wheat. And then we can populate basically our table. You can see here, this number here, 250, is the one that we computed in the previous clicker question. So this is the tabular representation of the production possibility frontier. Hi, a quick errata corrige. Before I mentioned, basically when I arrived to point C, that the economy was using 25,000 labor hours for producing computers and nothing for producing wheat. What I should have said is that actually it's 25,000 labor hours of computing basically for producing the wheat. Now, the intuition is the following, and I didn't mention before. So the production possibility frontier tells us the maximum amount of two goods that can be produced given their resources and technology. Now, we want to use all the available resources clearly in order to get the maximum amount of goods. Therefore, as you can see here, the sum of labor hours that is distributed between production of computers and wheat always has to sum to 50,000. So 50,000 plus 0, 40,000 plus 10,000, 25,000 plus 25,000. So here what I should have said is 25,000. And of course, if we devote 25,000 in order to produce wheat, with basically 1 ton of wheat per 10 hours, we get 2,500 tons of wheat. So let's look. In fact, when we populate the table, we get, for 25,000 labor hours invested in wheat, for the production of wheat, we get 2,500 tons of wheat. Thanks. Now, let's take now these numbers that are here. So the maximum amount of computers and wheat, or combination of computers and wheat that we can produce given the resources in this economy, 50,000 labor hours, and the basically the technology. And let's plot this one in a graph. So I'm gonna copy this right-hand side table just here. And I'm gonna call this point with 500 computers and 0 wheat, A. The second point B, the third point C, ultimately with point E that denotes when basically the society is specialized in the production of wheat. So let's start with point 8. Basically with 50,000 labor hours and 100 basically labor hours per computer, if we use all these labor hours to produce computers, we have this point A on this graph that has on the horizontal axis 500 computers and on the vertical axis the tons of wheat. So here you have 500 and 0, 500 computers and 0 wheat. Then we can plot the point B, 400 computers and 1,000 basically of wheat. And we keep going C, D, E up to the point where E is specialized in the production of wheat. So what you can see basically here in this graph, if we actually plot more points like A, B, C, and D, basically we can have a curve that defines our production possibility frontier. So this is the graphical representation of the production possibility frontier. Now, as I was mentioning before, basically a model answers a question. In particular, our question was how many of two goods, the maximum amount of two goods that we can produce given the available resources. Now, the production possibility frontier is actually a very useful model. Basically, can provide an answer to other questions. In particular, here we can use the production possibility frontier to discuss existence, efficient, inefficient, and unfeasible allocations. So, what allocations are efficient? So that use basically that gets the most out of the scarce resources. The one that are inefficient, that basically let some of the resources are unavailable, basically unused. And feasible, basically allocations that are not feasible given the technology and the resources. So here, basically, let's look at this example. Producing one computer requires 100 hours, and this is just the same, and tons of wheat requires 10 hours. How many hours are required to produce 3,000 tons of wheat and 100 computers? Now, pause the video for a second and try to provide an answer. Well, is 3,000 tons of wheat times 10 is basically 30,000 hours just to produce the wheat, plus 100 computers require 100 times 100, which is 10,000. So 30,000 plus 10,000 does 40,000. So the solution to these clickers is 40,000. So basically, let's plot this point that we just computed with 100 computers and 3,000 tons of wheat. As you can see, this is the F points that belongs basically in the set of possible feasible combination of tons and width, which is included in the production possibility frontier set. Basically, this is the production possibility set, and this line is the production possibility frontier. Now, my question is this allocation efficient, inefficient, or unfeasible? Well, as you can see from the title, this is an inefficient allocation. Basically, using the resources that we have and the technology that we have, we can get much more out of basically this economy. In particular, we could get, as instance, 30,000 tons of wheat jointly with more or less 200 computers. So we are basically underproducing the number of computers. Or we could get, here you say, basically 100 computers, and then eventually you could get 4,000, say, tons of wheat instead of 3,000. So this is an inefficient allocation. This allocation is not efficient because we could get more out of our scarce resources without sacrificing anything. So think about the following. During this COVID crisis, do you think our economy is on the production possibility frontier set? So it's basically on the production possibility frontier, is sitting on the blue lines, or is sitting outside or inside this production possibility frontier set? Pause the video for a second and think about it. Well, the economy in this COVID crisis is actually in an inefficient allocation. There are several people that are getting unemployed. There are a lot of resources that actually cannot be used. Now, I don't want to push it too much. That one basically, the concept of inefficiency is a constraint concept, which means given the available technology, and during a pandemic, we can do less, basically with all the available technology because of all the further restrictions that we have, social distancing, problem in having a client-supplier relationship, and so on and so forth. But I would argue that in general, during a recession, basically, economy lives in inefficient allocations. What does it mean? Basically, they could get more out of the scarce resources, as instance, by employing the people that are unemployed. So this, if you want, is an example of a recession, this F point. So let us analyze now this other situation, where again is the same technology, but now basically is asking how many hours are required to produce the following allocations of two goods, particularly 300 computers and 3,500 tons of wheat. So to produce this amount, we need 100 hours per computer, 10 hours per tons of wheat. So it's the 300 times 100 plus 10 times 3,500, which is 30,000 plus 35,000, which is 65,000. So the solution here is 65,000 labor hours are required in order for this economy to produce this allocation given this technology. But remember, we have only 50,000 labor hours. So do you think this allocation is feasible or not feasible? Clearly, this allocation is not feasible. And indeed, if we plot this allocation G, is outside the production possibility frontier sets. So if you want, is outside this blue line that defines all the possible bundles of goods, efficient and inefficient. Efficient if they belong to the blue curve, the production possibility frontier. Inefficient if it belongs inside the production possibility frontier. So basically the point number G does not belong to the production possibility frontier set. It falls off and therefore is not feasible. So to recap, we can use the production possibility frontier in order to establish what basically points are feasible, and given feasible, what are inefficient and efficient, and what points are unfeasible. In particular, all the points that we draw basically using the tabular representation, the point from A to E, A where we specialize in the production of computer, here where we specialized on the production of wheat, basically these points are possible, and plus, more importantly, they are efficient. So all the resources are utilized. If you remember our tabular representation, you remember that we were using all our labor hours. So there was not basically labor hours that was not used. Then we have seen that points like F are instead basically points under the PPF, so that belongs in the set of the production possibility frontier. Still they are possible, which means they are feasible, but they are not efficient. Some of their resources there are underutilized. For example, you can think about this as capturing unemployment in an economy, or factories that are idle. And last but not least, we look at points like the G point that was unfeasible. So given the resources in the economy and given the technology, that point could not be reached by this economy. And this is it about allocations that are feasible and unfeasible, and among the feasible, the ones that are efficient and inefficient. So let us move now to a new topic, which is basically topic number 2, where we use the production possibility frontier instead to talk about something else, in particular the opportunity cost. Remember, the opportunities cost is what you give up in order to get that. Now, in this economy, we have one resource, which is labor. And if we choose to use labor to produce computers, we give up wheat. If we use labor to produce wheat, we give up computers. Remember our example where we were walking in the trail, where we were using the scarce resources was time, and we could use time to go left or time to go right. So again, we can use the production possibility frontier in order to understand what is the opportunity cost that a society faces when it chooses to produce one good versus another good. So the PPF and the opportunity cost. The slope of the production possibility frontier is informative about the opportunity cost that an economy faces. Let's look in turn. So let's recall the definition of a slope. The slope of a line is the rise over the run. That means the amount the line rises, the rise, when you move to the right by 1 unit. So the slope of the PPF equals how many tons of wheat, the vertical dimension, do I get if I produce one computer less? Actually, here we are moving from the right to the left. So if I produce one computer left, I can reallocate these labor resources to produce wheat. So I can move, say, to this point. And I keep going, and I keep going, and I keep going, basically in this process. So the slope of the production possibility frontier tells us the opportunity cost of a computer. Opportunity cost of a computer is that I could use the labor resources that produce this computer to produce wheat. And basically with these resources, so to produce one computer, you need 100 labor hours. So you can use these 100 labor hours to produce as many tons of wheat as you can. Well, you need 10 labor hours in order to produce 1 ton of wheat. So basically to produce one computer, we are announcing to 10 tons of wheat. Please pause the video if this reasoning was too fast and go back basically to the technology. So moving along the production possibility frontier involves shifting resources, in particular labor, from the production of one good, computers, say moving to the left, to the other, which is the wheat. So one computer less, let's repeat, basically make an example here. One computer less means that now we have freed how many hours? Well, 100 hours of labor that we can use in order to produce wheat. Now, 100 labors, how many tons of wheat they produce? Well, 100 hours divided by the 10 hours per ton of wheat will tell us how many tons of wheat we can produce, which is 100 divided by 10 hours per wheat will give us 10 tons of wheat, which is how we get this number. So the society faced a trade-off, and the trade-off is between basically one good and the other. Producing one of the good requires sacrificing the other. So in this case, basically, economy has to choose what to produce. The economy can, just to give you an idea, The economy can produce any bundles of goods that are contained in this triangle between 0, 500 and 5,000. Okay? Now let's forget about the inefficient allocation. Let's consider only the efficient allocation that are given by the blue line, which is the production possibility frontier. So the production possibility frontier is telling us that the society can choose each one of these bundles. Take into account that when you renounced one good, you get the other good. Or if you want to produce more of the other goods, you have to renounce to one of the other goods. So if I want more computers, I need to renounce 2 tons of wheat. And a way in which basically we can compute the slope is just by using basically, if you want, the basically intuition here, you can divide 5,000 by 500. This one will give you the rise. Since here the slope is constant, you can get the rise 5,000 divided by the run, which is 500, or 1,000 divided by 100, which is minus 10. So the opportunity cost in this case of producing one computer is equal to 10 tons of wheat. If I move to the left of 1, I get 10 more up. Okay? So we can use the slope in order to measure the opportunity cost. So in which country is the opportunity cost of clothes lower? In France or in England? Please pause the video and think about it. Okay, so basically the opportunity cost, first of all, when you want to try to address this question, fix the good for which you want to compute the opportunity cost. Remember, the opportunity cost of going left is going right in our trade. In this case, the opportunity cost of which good is the good that we are selecting as the base good is cloth. So we have to fix, if you want, the horizontal axis. And basically the slope that you get here, so if I renounce to the, basically if I produce one cloth more, what am I renouncing? Well, I'm renouncing to a bunch of wine. If I produce some clothes here more, I'm renouncing to a bunch of wine. So France and England, basically here we are studying which one of the two countries have a higher opportunity cost of producing clothes in terms of wine. Well, you can see that if we produce one cloth more in France, well, we have to renounce 2 tons of wine. In particular, 600 divided by 300 is 2 of wine. Does it make sense? It's 600 divided by 300. This is basically the rise over the run, is the slope that is telling us the opportunity cost. And it's telling us that basically 600 divided by 300 is 2. If I want to produce one close more, I have to renounce to 2 of wine. Conversely, in England, so what is the opportunity cost in England? Is 200 divided by 300, which is around 0.6. So where the opportunity cost of clothes is lower? Well, it is lower in England. So the answer is number B. In France, you have to renounce to 2 wine to produce one clothes, while in England, you have to renounce to 0.6 wine. So England has a lower opportunity cost of producing clothes. Just, such that when you face this type of exercise, you understand well how this type of trade-offs work. Now, in this case, we are asking the opportunity cost of basically clothes. So the opportunity cost of the horizontal axis. Something I always like in exams is to experiment also with the vertical axis. So which one of the two countries has a lower opportunity cost to produce the wine? Well, it's the opposite. In this case, France has a lower opportunity cost to produce the wine. While, because to produce the wine, you have basically here, in this case, the rise will be here, 300. The run will be here. So the slope is this object here, which is 300 divided by 600, which is a half. While instead here, the opportunity cost, which is given by the slope as measured on the vertical axis, will be 300 divided by 200, which is 1.5. So always think about what is the goods for which you want to compute the opportunity cost. Okay? If you go left, the opportunity cost is right. If you go right, the opportunity cost is what you're giving up, which is going left, in the case of our trail. So let us conclude our discussion by using the production possibility frontier in order to answer actually a very important question. So can we use actually this very simple model in order to illustrate economic growth? So can we use this very simple model that just tell us what is the maximum amount of two goods that you can produce given the amount of resources in the economy in order to actually get insights about economic growth? And this is something that we are going to use as instance in chapter 12. Well, how can we capture economic growth using the production possibility frontier? Try to pause the video and think about that. Well, economic growth is basically, we are going to learn in chapter 12, that is due basically to the accumulation of some of the factors. That could be physical capital, labor, natural resources, or more important than all of them, technological knowledge. So if we increase the amount of resources that are available basically in this economy, say we get for each one of basically for the same existence amount of labor hours, we get more productive. Say we don't need any more 100 hours to produce a computer. Now we need 50 hours, and we don't need any more 10 hours to produce a wheat, 1 ton of wheat, but we need 5 hours. Then what we get a push of the production possibility frontier to the right. So economic growth, what it does, shifts the production possibility frontier upward. Okay? Notice, in this case, we have a parallel shift of the production possibility frontier. Why is this the case? Because it didn't change, if you want, the opportunity cost. As instance, if I take half of the resources to produce basically the computer, before basically was 100, now is 50, and you take now half of the resources to produce 1 ton of wheat from 10 to 5, then what you get is that the ratio between the two, 50 over 5, is still 10. Before was 100 over 10, which basically the ratio, the rise over the slope was 10, so the opportunity cost is basically the same, okay, in this particular example. You can think about, though, as economic growth, that shifts, if you want, this line not in a parallel way. Say there is economic growth, there is some technological knowledge that makes agriculture, say, more productive, and then basically you will get that the computer, same basically but there is no technological knowledge improvement in the computer, in the technological sector. Then you will get that you still produce the same amount of computers, so you get this black line, and there is just a shift, basically, of the tons of wheat. Basically, we move only in one dimension and not in the other. Okay, this is just to make a thing. Again, this is just a review of what you've seen in Principles of Macroeconomics. So, last but not least, and you can see how rich is the production possibility frontier model, the shape of the production possibility frontier, so far we have assumed that is actually basically a straight line, but in principle, the production possibility could actually even be bow-shaped, right? And basically, it really depends on how the opportunity cost changes as the economy shifts the resources from one industry to the other. So if the opportunity cost when you shift the resources to the other remains constant, then the production possibility frontier is a straight line. Conversely, if basically the opportunity cost changes when you shift the resources from one, basically the production of one good to the production of the other good, then the production possibility frontier becomes bow-shaped. Let us give an example. Let us think about the following. Basically, think about here, basically we have beer as one of the goods, and you have mountain bikes. Think about, as instance, your class, or the class of your peers, that basically where there is a distribution of basically students, and each one of you basically has a different talent. There is a bunch of you that actually is very good in producing mountain bikes, and there is a bunch of you that is very good in producing beers. But not all of you have the same characteristics. So there is someone that is very good in producing beer, but is not so good in producing mountain bikes, and someone else that instead is very excellent in producing mountain bikes, but is not so good in producing beer. By the way, this is very boulderish as a type of example. So let's suppose, as instance, that what I'm going to do, I basically allocate all the resources, basically, of the class here in producing mountain bikes. Okay? And let's suppose that among these resources, there is, I don't know, Beth. And Beth, she's actually amazing in producing beer, but she doesn't really know how to produce mountain bikes. So I'm using all the resources in the class to producing mountain bikes. So I get basically, say, this number of mountain bikes, 100. Let's suppose that now I release Beth and I let Beth produce beer. Then just because of leaving Beth producing beer, bam, we get a huge amount in the production of beer. Why? Because she was not really adding anything to bike. What does it mean? If, I produce so many less beers and I put Beth in producing bike, there is not really much of bikes that she can produce. But conversely, she's amazing in producing beer and etc. And then you can keep going. You can think about, say, John, that is almost as good as Beth in producing beer, but then is not very good in producing bikes. So if I release him, bam, I can produce a lot of beer and I have to renounce to just a few mountain bikes. Okay? And you can keep going up to arrive to these other points where instead you specialize the entire economy in producing beer, and where there will be people like, I don't know, Steve, that instead is not able to produce beer at all, but if you let him produce mountain bike, bam, he can produce a lot of mountain bikes. So, as the economy shifts the resources from beer to mountain bikes, basically the production possibility frontier gets steeper. And this captures, if you want, the idea that there are individuals that have different skills in producing each one of the goods, so the opportunity cost is not always constant. When you allocate people that are very efficient in producing one good on the other, you don't get much out of them. And this one creates this bow-shaped production possibility frontier. So the PPF might be bow-shaped because individuals have different skills and different opportunity cost of producing one goods in terms of the others. And the PPF would also be bow-shaped when there is some other resource, as instance, a mix of resources that varies basically in opportunity cost. Example in agriculture, different types of lands, and so on and so forth. So the PPF in summary, the main goal at the beginning of the PPF is to show, give me all the amount of resources and technology of this economy. I can tell you the maximum amount of goods that you can produce with that. Because of this, we can determine which allocations are basically efficient, which allocations are inefficient. Then we can use an unfeasible. Then we can use the production possibility frontier also to explore basically concepts like trade-off faced by society and opportunity cost. Basically, when the society decides to put the scarce resource in the production of one good, as to renounce to the other, as measured in terms of opportunity cost. We discuss efficiency, inefficiency, and feasible. And then we discuss the concept of economic growth. We can use the production possibility frontier in order to talk about economic growth. Last but not least, basically a bow-shaped production possibility frontier illustrates the concept of increasing opportunity cost. When an economy is specialized in the production of one of the resources, might arrive to a point in which the opportunity cost might be very high of producing these resources. So maybe a little bit of mix in the production can alleviate basically this type of problem. Let us now introduce a couple of very, very, very useful concepts, which is the one of normative and positive analysis. Now, positive statements are statements that describes the world the way it is. As instance, the Federal Reserve is, during the COVID crisis, decided to print money. So the Federal Reserve prints money is a positive statement because it describes the way it is. Now, positive statements are different from normative statements, which instead describes the way in which the world should be. As instance, an example of a normative statement is the one where we say is that the Federal Reserve should print more money. Now, the should if you want, reflects a system of values. The normative statements in general are coupled with a system of value that will tell you what you should and should not do. As instance, religions, and if you want, many philosophy, they provide system of values, way in which they tell you basically in which you should act, which is different, as instance, from positive statements that instead just describes the way in which a phenomenon is. So, let us now conclude the chapter by introducing a very, very useful concept, the one of causality. Now, economists like to make causal claims, like to make assertions like if the government prints more money, then we are gonna get out of this recession faster. If the government introduces a stimulus, then we are gonna make this recession less painful. Money. So, when we make causal claims, we really have to be careful. In particular, when we make causal claims, we have to be careful. In particular, we don't want to confuse a correlation with causation. We don't want to confuse the fact that two phenomena, if you want, seems to move together with the fact that actually one phenomenon is causing the other. So when you want to make causal claims, you have to be worried about two things: omitted variable bias and reverse causality. Now, omitted variable bias is a very tricky one. And the intuition is the following. Think about two phenomena, like the number of lighters in a house and the risk of cancer, that are correlated within each other, but they do not cause each other. And in particular, both phenomena depends on a third phenomenon, and in particular this one will be, as instance, the likelihood of smoking, that cause both of them. And therefore, these two phenomena are correlated, but they do not cause each other. So omitted variable bias is the idea is that when you use graph, it's very easy to fall in the fallacy of making causal claims just because you see a correlation between two phenomena. And what you have to be careful, what you really want, is you want to think about whether these two phenomena would be correlated within each other if you control for a third phenomenon that maybe is causing both. As instance, if you plot the number of lighters in a house and the risk of cancer, the two you will see that are positively correlated, but it's not that having more lighters in the house causes cancer. The fact is that possibly the number of lighters are related to the fact that the number of lighters are related to the fact that maybe there is a smoker in the house, and smoking actually increases your likelihood of getting cancer. So although the two are correlated, they are correlated because of a common cause, the omitted variable. But once you control for the common cause, so once you control, if you want, for the number of cigarettes smoked in the house or something like that, a measure, if you want, of how much basically smoking is going on in that house, you will see that the number of lighters and the risk of cancer is actually uncorrelated within each other. You will not see any pattern. The problem of reverse causality is another tricky problem that you might incur to when you want to make causal claims. And the idea is that when you make causal claims, as instance, using a graph, you really want to make sure that you understand which one is the causes of which. As instance, let's suppose I'm plotting the number of police, basically a police force per county and the number of violent crime per county or per city. And then what you will see is that the two are actually positively correlated. But the risk is that maybe you might interpret this as the number of police. Okay. You might be tempted to think that an increase in the number of policemen or women basically causes more violent crime, while maybe is the opposite. Having more violent crime causes actually to have, if you want, larger police force. So you always want to be careful.